So reInvent's coming up, so there'll be lots of cool stuff. And that's it. So I don't think there's anything else. No.
Warwick
can introduce Warwick.
Excellent. Thank you, Matt. Our first and only speaker, the last one for the year. It's so exciting. This is going to be a great presentation. Titled Large Packet Serverless. This is the description. With back-end, I forgot the acronym. Hang on, I just checked it. Geographic Information System. Should look it up. Data that gets appended to each week. Full loads for dissemination of the data are ill-advised. Warwick has implemented a large-scale incremental serverless data ops ETL and distribution system that utilizes Postgres, Postgres dumps of spatial data with big map brand, locality boundaries, addresses, etc. These are distributed through a S3 pre-signed links via the REST API gateway request response and applied to a multitude of client database instances. It sounds amazing. I want to learn more. It's yeah, I'm still processing that. So I think we're going to learn a lot in this presentation. Please welcome Warwick.
I'm here. Does that actually sit on the angle? Only just. Okay. My kids are going to ask, who was there? So I'll just get a photo of you all. Thank you for that. Hi. So I'm Warwick, and I'll get back onto that. Play. All right. Good. So about me. I started with a science degree, and I've been working in government for 21 years now, which sounds like a long time, but it's been 1, 2, 3, 4, 5, 6 departments, and it's still the same job. So it's the job changes, the group changes, but yeah. I've been loading VicMap weekly data supplies since 2006, which again, a long time. And things have changed in that time. So it's not just rote doing the same thing every week, because there's always changes in data which break the systems. So there's always something to do. And my old boss retired last year. He took a package, more government redundancies, which we're going through a big round of at the moment as well. So I've also got his job now, which is the data modeling and the in-house supplies, change management, all the horrible stuff which I used to have to not deal with. I don't have to deal with that as well. AWS I've been working on for 6 years, since about 2017. And I've got 2 cats, 2 kids, 3 chickens, and an inherited macOS genealogy application after my dad passed away in 2008. So I've been putting out a yearly release for this macOS app at the same outside my job. So that's my hobby. Well, yeah, it's a compulsion, let's say. And there's chickens. I like puzzles. Anyway, that's nothing about me. So what is VicMap? So the data suite which I work on is a set of vector data sets of point, line, and polygon. And it's the Victorian government data for where your property boundaries are, where your address points are. The topographic comes into it with roads and rivers and hydrographic and yeah, topographic. So there's a big suite of data. There's 630 layers, as I said. So on the left-hand side, you can see the these are the banners on the left and right, which I have to walk past every day when I go into work. I just thought I'd put a photo up there. So you can see you can build, when you're using a GIS to make customized mapping, you can build, use this data to build your map and to show what it is. These base maps are built off it. You can see there, in the middle, there's the VicMap schemas, the VMAD, VMadmin, VMCelopenia. They're all different classes of spatial data, whether it's property or whether it's hydrographic. And there's some sample tables there for the property layer, so parcel, property, etc. And you'll see there you've got something like you've got parcel and parcel view. So parcel is the aspatial details, and parcel view is the one with the shape column. So when you're working with spatial data, you have a geom column in your database, a geom in PostGIS, or shape in Oracle, where we used to work. and it takes up a lot of space, as you can see by the size of those tables. And it makes life hell when you're loading big data, because the spatial indexes and the size of each row actually make the operations really slow when you're working with a database. And so you've got your normal indexing. You know, if you have a large table with indexes on it, as you update the table, you're also updating the indexes at the same time, so things slow down. And with spatial data, it's a nightmare. And digital twin is being pushed a lot at the moment. I just thought I'd put that up there. They've got they take feeds of the data and put it out as web services. So what does VicMap exactly compose of? So we've got some load schemas, and our data supplier gives us a weekly load of the data, which they combine from sources around the state, like local councils and so forth. And I load what they give us into the VLAT and VTT schemas up top and the bottom there, and then percolate it down into the products which we put out. And products are what people are using in their GISs, the the roads layer or something like that. And the MISC is the in-house loads. So 575 layers there. I think that's wrong. Just missing something when I put this slide together. So next one. Here's the data flow of what happens. So the data comes in. Just use LAT supply schema as an example, and you can see what Darren here gives me. So he gives me the add and delete layers, and then I apply them to the load schema. And so I receive the incremental supply, and I apply it to the full data set that adds and deletes and updates. It's actually, more updates than deletes. And then I have some views, Postgres views, which make the super views, which have the history, and the normal VicMap products. I then difference that with the current product and get the deltas out of that. So this is the tables I'm supplied on the far left are sort of super schemas. They then get split up and merged with other in-house tables to create the products which people, that's what they use every day. So they don't actually know anything goes on the left-hand side there. Eventually, I get products on the right, which is good, but I have these artifacts in the middle, which are the deltas. So this is what I built to do that, and it's a serverless architecture. So you can see the 79 local government authorities. There's Phillip Island, Bass Coast Shire, one of 79. That comes into the integrated maintainer, which is Jacobs, and they give us 3 products. They give us the VLAT product, which is the land administration themes, and they give us the VTT, which is the topographic themes, and the IUF product. Now, the IUF product is a very old format. I'll get into that more on a future slide. But as you can see in the green box is what I'm using as my processor each week to load this data. So I check their bucket. I would like some kind of notifications to kick this off, but at the moment I just do a file listing of their bucket. If there's a new supply, I pick it up and I load it into my environment. The conductor, that's the orchestrator. So the conductor controls the orchestra. And the conductor then kicks off a series of state machines, which does a preload QA. That's the load of the data into the load schemas. And there's some basic QA that happens there, such as row counts and checksums. And then it goes into the next state machine is the QA ops. And the QA ops is the thing that's doing those comparisons, those differences. So the QA ops puts those deltas into the bucket using a PG dump. And then after that, then to publish the data, I'm actually publishing the data down here on the bottom right corner in DataShare and via network. But to get it there, I have to go through a platform which was built by another part of the government, and it's full of bugs and it takes a very long time. So I've been trying to make a shortcut to get this data to the customers without having to go through this publication platform. Peach is bad, think red. So what I've built is the small green boxes on the bottom there, the VicMap Manager API and the VicMap Client Instance, DeltaVic. And they source the Postgres dumps of the incremental product data from the bucket, and push it out to the users. Each of these steps has you can see the control database there up the top line. So each of these steps has a set of tables which have a status in them, and the status determines what happens next. It's queued, importing, adding, deleting, indexing, and it steps through those steps for each layer that it's loading. What we have on the bottom left is the VLAN IUF. The IUF format just comes in and bounces off my bucket and goes out to an SFTP server. Now, the SFTP server on Amazon is $200 a month, so I want to get rid of that as well, because that's $2,500 a year I can save by not having that sitting there. So the whole system costs about $2.50 a month to run that green box. Down here we have FME Server, which is a third-party application written by a couple of guys from Vancouver 30 years ago, Don and Dale. And FME Server is it's very popular in the industry. It'll take any spatial data format and transform it to another format. If you want to go from Oracle to Postgres, or you want to go from Microsoft SQL Server to a shapefile or a map info format, then it can do that for you. So it's everything wrapped up in there. But unfortunately, I'm using it to make FileG databases, which are an Esri format. Esri is one of the large global providers of GIS software. So the people that sit on their desk and use the GIS software in government are mostly using Esri products. There are free products out there like QGIS, and I would encourage anyone to use that as an alternative. It does the same job, and it's open source, so it's free. But FME Server, so $2.50 a month to run the conductor. FME Server, it's sitting on a large $300 a month machine. The database is also sitting on a $300 a month machine. I'll explain that further in a minute. And then the licensing for FME Server is about $70,000 a year. We've got a dev and a prod instance. It's 24. They just put their prices up, so it's $24,000 per engine, and you need multiple engines in each environment to run it. So $2.50 a month is where I want to stay, but I've got all this other infrastructure that costs a lot to the people that employ me. Yeah, okay, moving on. What's the other thing I was going to say? No, lost it. That's all right. I'll move on. So here's the Lambda design. Each of those state machines has a main Lambda, and then the rest of it is just a dollar complete event packet variable. Says, am I complete or am I not complete? And if it is, it's finished, it's ended. So you might have 20 layers to process, and you'll come in here. If you're processing, let's say you're processing the FME file or the VDP, I'm relying on other systems to then give me a job ID and let me know when the job is done. So I farm out the job and I wait for it to finish, but the state machine keeps running until I poll it every couple of minutes. I've got an exponential backup there, and eventually it says I'm finished, and eventually there's 0 data sets left and the state machine shuts down. Yes, Lambda design. So we've got a layer on every Lambda. You can see on the top left, top right there is the Lambdas I'm using to, I don't know why I ticked the box. That's the one I haven't finished yet. But the conductor, VML conductor runs everything. And then the loader, the ops worker, the FME worker, the VDP worker, they all run inside state trees. Each one has a layer which is called Dataman. And the Dataman layer contains, everything I'd want to do in AWS or anything I want to do with a file system, which underlies it. So yes, there's an EFS underneath each of these Lambdas, which is shared between the Lambdas. So they're in the same security group, and every Lambda can see the EFS and put data there and get data from it. So each step of the load, when FME finally comes back and says, I've finished your file database, I put it on the EFS, and then I pick it up from there in the next step when I push it up to the VDP. So on the EFS, I have 3 folders. There's a SQL folder, which holds the hundreds of SQL templates. So if I need to recreate the database, the data layer products I'm creating are stored there. So when I reseed the database, or if there's change management going on, I can replace the data. And there was a lot of information. A few speakers mentioned a data eng conference a couple of months ago. There's like data build tools, which will help you manage changes to a data schema. I'm not using any of that. It's just all basic, like here's a folder with all the SQL scripts in it. I should investigate that further when there's time. The lib folder is interesting because it has a Postgres client in it. So the Lambdas, when I originally built this back in before May, I was using Python 3.7. And when I pushed it up to Python 3.9, we moved from Amazon Linux 1 to Amazon Linux 2 as the substrate for the Lambdas. And so you've got to target the Postgres build to the machine which the Lambdas are running on. So these Lambdas are running, they're all Python 3.10 now, so I can use match case, and they're all running on Amazon Linux 2 under the hood. But you find out that the Amazon Linux 2, which runs a Lambda, is not the Amazon Linux 2, which you get when you fire up an EC2 with a AL2 on it. It's missing a whole heap of things. They've made it smaller, faster, more efficient, but it's missing all these .so libraries. So the C linking libraries, they're just not present on that Lambda Amazon Linux 2. So you run it on an EC2 and you're like, great, it works. And then you run it on Lambda and it's like, why isn't my Postgres client working? So what you have to do, you have to fire up an EC2 with Amazon Linux 2 on it, install a Postgres client or Postgres server plus the client, and then you take the folder, the client folder, and you put that into the EFS. And when you make a PG dump or a PG restore for the Postgres, you have to call the client on the EFS to do it, but you also have to add in these extra missing .so files. So PG dump in that middle column, PG dump and PG restore are the only two I use there. And they're the ones that do all the work for my application. This is my desired state. So whereas before we had this data maintainer integrator here, Jacobs, they're on level 6 here. That's got 18 months left to go in the contract, and there's a desire to bring that in-house to do a lot of that processing, and then to have them run projects on the data without actually integrating it. So what I need to do over the next 2 years is to build a system, well, next 12 months really, to build a system that can integrate that data from the LGAs. And that's why I've got these two-way arrows here. So okay, back here again. So the bottom right-hand corner there where I've got those peach squares, I want to get rid of that because it takes a long time. So this redesign allows the person running that VDP to be a customer rather than a distributor of our data. So I'm now distributing the data, and they are, if they want to use the data, that's fine, but they'll have to load it themselves because that stuff takes hours, plus it takes $70,000 a year in FME licensing, which I'm not willing to stomach. So I built the VicMap Manager APIs and the client application, which you can see on the left-hand side. The organizations listed down the left-hand side there, except for the 1,000 GISs at the bottom, the current customers of the IUF, pretty much. So the incremental update format, it is on a later slide. I will get there. But they're my target audience for this Delta Vic application I've built. We've got a clip, zip, and ship down in the bottom corner here. If I walk away from VDP, I lose that front end, which is distributing the data. And so I could build a GDAL GEOS EC2. GDAL GEOS is the open source spatial transformation libraries that is actually under the hood on FME. And all they've done is put a pretty wrapper around it. And yeah, so I could build a clip, zip, and ship to allow people to say, I want this data set in this format for this LGA. So they'll get property for Bass Coast in a map info format or something like that. But my proposal is, why would you bother doing that? That's why it's optional, because what I've built can give you the whole instance of VicMap. So you're not requesting a layer anymore. You're not saying, can I have the roads layer? you're saying, I want VicMap as a whole, all 630 layers on my local, it can be a local computer, 1,000 GISs, and I want it to be in sync every week. So the deltas provide the mechanism to check hourly if there's new data. So you set it on a Windows scheduler or a Confab, and it will check if there's new data from my manager. It'll ask the systems, and that will keep the remote instance in sync. And they have what I have an hour later. There's a big possibility for me making huge mistakes here. So yeah, but the control database at the moment, in my environment, the data and the control database sit on the same Postgres instance. So I need to split that apart. You can see I've got the DynamoDB control there, and that could just be a little $30 a month Postgres instance. It doesn't have to be DynamoDB, and I think I prefer that because DynamoDB, you've got that eventually consistent thing, which means it's not real time. So you wouldn't want to base, is my state machine running, when you might have jumped in half a second before it's actually updated itself. So I think I'll actually have that control database as another Postgres instance, so that the requests you make about the state of the application are actually true. So yeah, splitting apart databases, that's still on the to-do list. Next steps, DeltaVic. So since we have the artifacts from the load process by using pgdump, we should also distribute them and have 1,000 copies of the data. You know, why not? So the main screen there is one of the folders in my bucket, and that is the address incrementals, and there's a DDL it dumps as well. Every time there's a full supply, it dumps a DDL of the data, but I haven't found a use for that yet. And down the bottom, you see the address, the main address full dump of 220 megabytes. And then you can see the weekly stuff is, you know, down to 1/5 of a megabyte. You know, under 5 megabytes mostly for the address data, which comes in each week. So I'd much prefer that people download these little deltas and apply them to their systems than use up the bandwidth of doing a clip, zip, and ship thing and downloading that 200 meg every week just to update the few addresses which have happened. So yeah, on the left is my horrible thing. Well, it's a beautiful thing. I did call that the chaos because the chaos kernel, so you've got control database, and this is chaos kernel, because when things go wrong in that second gray box here, it cascades. Like if I have a bad load, which does happen sometimes, and there's some missing data, once it gets past that preload QA and does the checksums and so forth, if it's past them, and if the checksums happen to be wrong, then it will start propagating all this stuff to all the other systems. So yeah, you have to be, there's a lot of QA that needs to keep you safe. Sometimes you can't prevent it, but when accidents happen in the chaos, it's really hard to pull down those state machines and make them stop working. RDS metrics during a VLAT load, a couple of VLAT loads. What you'll notice here is the EBS byte balance from this Postgres instance dips right down close to 0. And it took me a while to figure it out. It's the Postgres dumps, because EBS byte balance is the reads and writes from your disk on Postgres. So I did some testing, and I took out the, whoops, scrolling on the wrong thing. So I looked at, if I take out the AnalVac, which is, it's like colonic irrigation for your database. It doesn't analyze in a vacuum. And it didn't make much of a difference. So yeah, I still see that big dip happening. So the only thing left that was running was the Postgres dumps. So that's a gotcha that you have to watch out for. Finally, you get to see what the IOF looks like. It's an XML-based format of points, lines, and polygons in XY coordinates and big long chains. You can see on the right-hand side there, there's a large one further down the file. Just goes on and on. So for the history of this, about 2004, maybe a little earlier, the IOF was developed, the incremental update format, and it was this XML, and we used to load all of the data this way. And we'd have a customer-facing IOF, and we'd have a server-based IUF, which was one which we used. We changed contractor from Logica to Jacobs about 2010, 2012, and we moved to using SDE exports and Oracle dumps, so we didn't have to pass the XML anymore, and that was a great advance. And then last year, when we moved to the new platform in the cloud, we started using Postgres dumps because we no longer wanted to pay the Oracle licensing, and it's just better to use a free database than an expensive one. But the problem is that the customers we had in 2004 are still using that old IUF format, and I kind of pity them. So yeah, we've got to get them off that format, and that's why I'm doing this. The advantages of this, so if you have that IUF format, you're not going to get anything like indexing or anything like that. If I have Postgres dumps, along with the Postgres dump comes all the indexing and constraints, which that table owns. So every time they do a full load, they're loading fresh indexes, and when they apply the incrementals, those indexes get updated. And it's better on the bandwidth. And if a data set changes, we have a nightmare with change management. If we want to add an attribute to a table like address or something, we want to add a local government area to the address or something like that, we then need to go through a 3-month change process where we tell the customers what's going to happen, and they prepare their systems for it, and then eventually we make the change, and then they all cry because their systems fell over because they didn't prepare for it properly. So with the full dumps which I supply, when this change management happens, it just performs the change on their systems and re-indexes it, and it's fine. The other problem with the IUF format was that every council that implemented it, nearly every council that implemented it went off to one of the spatial consultancies in Melbourne. There's half a dozen big players for spatial consultancies, and they would rewrite an XML parser to get it into their databases. I've written the client for this new version because I want the onboarding to be really simple for the users. I don't want there to be any barrier to entry to using this. So if they have to go off and spend $30,000 at one of the spatial consultancies to get this done, then that's a barrier to entry, and they have to muck about. But if I just give them the client, and much more smooth sailing. And I had wanted to do this years ago for the IUF, but I knew that its days were numbered, so I didn't want to really push it. Now, the previous clip, zip, and ship methodology in services are no longer relevant. I mean, there's not much difference between 10 meg and 60 gig nowadays on our servers. So why would you struggle to keep your downloads smaller than the whole instance? I don't know. Just take the whole instance. It's easier and it's quicker. And there's also the rise of WMS and WFS. That's web mapping services and web feature services, which are kind of like REST services that feed out spatial data. So they'll see you're using your GIS in this geographic extent, and it will give you the data for that extent. So you don't have to download the whole state data to see what you are interested in. So yeah, clip, zip, and ship should end. Okay, enabling RESTfulness in API gateway from a SAM stack. I made a mistake here in using SAM. I started writing this this set of APIs probably about 6 weeks ago, but I thought I haven't had much experience with SAM and AWS Power Tools, so I used the two of them to build this out quickly. But I ran into trouble that when you set up an API gateway with SAM, there's a difference between an implicit implementation and an explicit implementation. Implicit is when you say nothing at all and you give it very bare bones kind of stuff, and it goes off and creates a cloud formation in a standard. This is what you would do if you were doing the bare basics. When you want to do something more tricky, it gets harder because once you start going down that implicit path of declaring what kind of API stack, whether it's a REST stack or an HTTP stack, it's like a cascade of dominoes. You then need to start fleshing out this SAM template more and more to fill out not just the API gateway, but the gateway response types and all that kind of thing. And it ends up you're just writing CloudFormation in SAM. So what I wanted to do was I wanted to have the integration response when my Python code on the back end through a 400 error or a 400, 403. I wanted to actually have that coming out of the API gateway. By default, if anything comes back from your code, then that's a 200. So, and it's not okay. So what I found was that you have to turn off the Lambda proxy in order to get the integration response to be anything other than a 200 or a 500 server fault. You have to turn off the Lambda proxy, and when you do that, you have to then manually map the integration request and the integration response so that the JSON packet you're putting into the server arrives mapped, like readable. If it is proxied, AWS API Gateway will give you a whole heap, like masses of context and request parameters, event parameters, which are useful, but it's too much. All I wanted coming in was the body. I also had to do the method and the path because the AWS Power Tools are expecting the HTTP method and the path to be part of the packet it receives to run. So I worked that out. That was an all-nighter actually to get that fixed. And now it doesn't just give a 200 response; it also gives a 400, 403, etc. So one thing, it was a bit like Inception at one point where I had my return packet coming in as a JSON string into the body, and that's not what I wanted. So that number 4 integration response is where you take the status code you're actually providing and map it to the API gateway response with that little bit of code at the bottom there. It's the API schema I built. So this is for the manager API. It's got a registration step, and I manually verified these. So down under that second box on the left is the email you get when you sign up. So you hit the post register, sign up, it sends you an email with a confirmation link. You click on that confirmation link and it goes back to the same endpoint, but as a HTTP GET. It doesn't. It's not same endpoints. It's a verify endpoint. It's not on here. Purple. It's changed a lot since I wrote this slide. So try to keep it simple. So data and supply is all I wanted. Upload is something which I haven't implemented yet, but that's what I need to get that two-way interaction going where users can also give me data to put into my system and then I can distribute it for them. In the light gray there's a bunch of things that I considered building but didn't. When it came to writing a Swagger, it was conceptually difficult because depending the JSON request which I receive on these endpoints, I'm actually giving something different back. So here you see the supply and the data endpoints, which are my main workers. So if you hit the supply endpoint with nothing, just here's my client ID, please give me supply. It'll give you all of the supplies which have been loaded in the VicMap environment. If you hit it with a supply ID, it'll give you the details about that load. I've got some observables there for the start and the end times of all of the state machines which are running in that load. My stuff all finishes quickly. The dependent systems take forever. And the same with the data. You hit it with nothing, it gives you all the data sets. And if you hit it with a data set in particular, it will tell you the indexes, what loads it's done, and it'll give you this pre-signed link down bottom. And this is the heart of the system. That I put these PostGIS deltas in the bucket, and it gives you a pre-signed link to download that next file. So you tell it, I have address version 506. It'll say, here's the link for 507. You tell it, I don't have address. It'll say, here's the link for the full file. So link to the GitHub repo. So can you bring out your phones and just have a look at the client app? And then you can live criticize me if you want to. So, yeah, it's very simple little client app. There's not many files at all. It's got a Delta Vic executable, and it's got a Dataman folder, and it's got an app folder which runs either setup or sync. So client architecture for the Delta Vic client instance, and this is what I want customers, the Python scripts I want them to download so they can sync to the database to the local instance. It's very simple, but it just uses PG dump and PG restore. That's the key. Like Postgres dump, Postgres restore. It has a table locally called layer registry where it records the all of the layers and what version they're up to, and then that way it can request, I have this version, what's the next version? You can mark all the layers as false or true if you want to download them or not. But I have to assume a few things, like the target client will always want to have the latest version, will always want to be up to date. So very low minimum bar to use it. Any entry-level tech on 60K a year should be able to install PostGIS in Python and clone the Git repo. So there should be someone in every organization who can actually help with getting this running if the GIS person can't do it themselves to their local desktop. So I did run it. It is working. It's got bugs, but I'm missing some primary keys from the in-house data sets and so forth. But and those times are lengthy. It was just run on my desktop computer at work. If it's on a beefier instance of PostGIS, it'll run faster. And I haven't got up to the incrementals yet, but the code's there to do it. So, but I'm expecting it should only take 10 to 30 minutes to load all the fresh data each week onto each of the instances. And I'll finish that next week, probably. I also wrote, from the Manager API, I wrote a Swift UI app on my phone just to truth the endpoints. So you can see the middle one there. It's got the VLAT loads on the left and the topo loads on the right, and the miscellaneous in-house loads in the middle. There are more loads than that, but I stripped back the dev instance to nothing while I wrote this. That smaller one here, that's actually photoshopped with a bit of JSON and the graph. The graph shows the work which I'm doing. So the first two bars on the graph are import and loading of the data, applying it to the local store. Whoops. The third line on the graph is my Postgres dumps. And it's probably the first 10% of that is the incremental dumps, and then it goes off and does the full dumps in case there's a new customer who hasn't got any of the data. It needs the latest full version of the data set in the bucket. And those bottom lines, the first large line is making the FileG databases using FME, and the last two large lines are then uploading those FileG databases to the target vector data platform, which then distributes the data through DataShare. So if I can get them to load the data themselves, all I have to do on my database is have those first three lines of the graph, and then they can load it themselves and deal with their own bugs. That's better for me. But yeah, and it also shows the data sets, so you can click on them and see the history of the loads of that data set. Not everything is loaded every week. So it's a seed load, and then the incrementals might be based on projects which are changing the data, but like you wouldn't change the rivers data unless there's some large LiDAR project to remap the rivers and something like that. So, and that's all I have for now. So, and there's a happy new year because it's the last of the year.
Any questions?
Yep.
So I saw a lot of the state machines you had were more like computational, but I saw maybe on the final part during the chaos, you actually had for your BDP. Is BDP served over like NFS?
No, that's a different set of APIs which they built.
So it is. That's one of the only machines that is actually awaiting calls, or does it just send off and forget, or is it like a waiting call?
It's a waiting
for VDP.
Yeah, so FME and VDP both wait for a job ID to be marked as complete.
Yep.
So it's just polling.
So,
Yeah. So that works. Yeah.
Question. So you mount EFS in Lambda.
Mhm.
What is the cost? Can you share how much you pay?
Well, EFS is elastic. It's very small, and I delete the that's in that $2.50. Yeah, that's in the $2.50 a month. It's as the data process is complete, they clean up behind themselves and delete the temporary files which are sitting on the EFS, so it doesn't grow. It's got a bunch of SQL scripts and it's got a Postgres client. That's the only thing that lives there forever. So yeah.
I was doing it correctly.
Yeah.
So I was crying after getting the bill. Yeah.
Oh, right. No, just temporary storage.
Processing EFS. Don't do that.
Mm.
Frugality.
Yes.
Yep.
Yes. Yeah.
So one of the things I have to do with this is to shut down that $300 a month database, because my processing is actually only 4 hours a week, like 2 to 4 hours a week. So my Postgres dumps are done within an hour and a half of receiving the data. So the problem is having that control database in the same one. I can't shut it down because then the APIs are talking to the control database to find out the latest version. So I need to tear them apart and have the control database separate so I can shut down a big expensive database. Something I didn't mean to mention, it is a big database because the Postgres dumps will process faster on a larger database, and to fit within the Lambdas in 15 minutes, I would love it if I could make an asynchronous Postgres call where just load this and I'll be back, but you have to wait for it to finish because it's running on your Lambda. It's reading it from the local file. So yeah, that's why it's large, but you can get away with something smaller. So if you're running this on a desktop, it doesn't matter how long it takes because it's just always going to be there. But if you're running it in serverless, running these Postgres dumps on large data files is time consuming. So. Yep.
You now develop on this?
Yeah. No, it's me.
So what happens if you see?
I just do it from home. Like the loads each week are easy enough. They're just a couple of hours on a Friday night where I have to monitor it. And also now I have the phone app. So like in January there's a load which is happening, and I'll be in Wilson's prom, and I'll just be able to start and stop it from there. So because at the moment I have to log into my work machine, I have to log into a virtual desktop, then log from there RDP into my desktop machine at work, and then log into a remote server. I have to log into an EC2 for an environment. From there, I have to log into the FME server, which is running the jobs for me, because that's the only thing that can see the database.
So you're saying
Because of the security
critical
groups.
piece of Victorian infrastructure has a bus factor of 1.
Yeah, pretty much. Well, there's more than one critical person around, so yeah, yeah. Yeah, it just ticks along though, so it's all right. It's well written. Yeah.
It sounds good.
Does, yeah.
Let's see.
Anybody's hungry?